All right, before the break, we were taking our first look at the object-oriented programming, some of our key vocabulary words. I defined a couple of them, wrote them up there on the board. I used several others that haven't defined yet, just as preview. You'll hear them eventually, but I'll go ahead and start a couple of sentences now. You're probably wondering what they were, some of those words meant, but you'll find out all that along the way. So introducing it. Big thing for us is encapsulating, taking everything that it means to be our new data type. So for, well, two quick examples. The first one is going to be drawn out on the board clearly with the diagrams like you have to draw. And when you turn it into the homework, you're going to have a nice polished, finished, something that looks really fancy like the diagrams in the textbook. Let me grab one from the notes in the Java class. A few weeks ago in the Java class, I can remember how to turn this on. How do I open this? Which side opens? That's the camera. So that is, there we go. And here, this one. Yeah. That's it. So on the, there we go. So the UML class diagrams you're going to turn in and for your homework and what you see in the book are all polished, finished off. But that is when it's useful. Right? When you're planning things, you don't need that super highly polished one, right? The rough notes jotted down, it gives you a nice little square where you can put the key points and draw arrows connecting them. So there's two versions of the UML diagram, right? That nice polished off finished final version that you'll turn in at the end. But then the actual useful version that is an absolute mess that is very, very helpful in the planning phases. This was for a pizza ordering system we did in class, which I guess should be that way. Nope. That right side up. There's that right side up. I think it's mirrored on my screen, but it's a lot more UML class diagrams are a lot more useful in that mess. And then the polished off one, we just need that by the end somewhere. But keep in mind that it can be useful in planning things like that. Which I guess is what I'm going to reiterate on the board. Oh, oops, I guess switch back to the other game before I did that. This one, there we go. So for our example, let's think about like a veterinarian office. Let's do the animal example. We do there's different standards and y'all are doing cars. Actually, the one in this textbook, the car example you do in your homework was for about 15 years was the top tutorial for Pygame 1. And actually it still worked in Pygame 2. It was there for the first couple of years of Pygame 2, but then somebody so the object that you're going to make here was from the standard Pygame tutorial for about 15 years. It's just a little sub piece of it, but in video game development is when object-oriented programming really started to make sense. It's kind of a confusing thing, talking about data types, but let's say for our situation, we're in a vet's office, veterinarian office, and we have a database full of all the patients, so all their records, and we need our software to work with that data whenever people come in for appointments or for scheduling appointments, emergency calls and all that. We need the software to work with that database we have. So we need a way to represent that data in our software. And you can set it up manually, right? Put in some strings for names and numbers for ages and things like that. But it's always going to go together and we're always going to have that same data about all of our stuff. So it's a great situation for object-oriented programming. Instead of a bunch of different data types, let's just make our own data type, our own animal data type, and then it is the exact same the exact type of data we need every time. It's a virtual version of the animals that come to our clinic. So we'll kind of do it like a UML diagram. So we have the big box here. And up at the top, we have the label of it, an animal. And all of our patients have a few things in common that the vet needs to know. For our strip down trivial example, the vet needs to know their name, how old are they, how much do they weigh, and what sound do they make. So four properties. I'll just go ahead and write them as private. We'll ignore the private thing and go with the easy way. So we have name, and we're working in Python, so I'm just going to skip the type thing. Say we have a name. We'll type in what the name is. We'll have an age, weight. I guess we need one, the sound they make. Well, I need one more. What type of animal are they? Oh. I'll leave type off for now. Name, age, weight, and the sound they make. And the reason I was leaving type off initially is because then we can make subclasses, so we could have one child of this that is the cat. So it inherits all of this. And then at that point, we know specifically what sound it makes. It's going to say meow. Or the dog object. Which is inherits all of this stuff, but we know what sound it's going to make. Or we have a fish object, has all that stuff, and we say the sound it makes is like bloop or something. Sound of a bubble popping. So really, we could hold off on the sound one and then set up these properties whenever we go to do that. And there are a couple methods. We could build methods that we might need. Like is sick, is it just a checkup, or is it an emergency? Different behaviors we can work in, but build in methods that we might need. Name, age, weight. What's something that we're gonna, what's that?
Nature of the visit.
What was that again?
Nature of the visit. If it's emergency or, regular checkup.
I want to keep it somewhat simple. But all of that data would work in, right? That's what I was wanting to hear from y'all, some points on
Purpose.
to be. I need to think of a method. Maybe I'll put make sound here. I'll say make sound is a method. And then instead of storing that as data type, we'll make that a field. So our child objects will inherit that, and then we will we'll know what sound to make at that point instead of a generic sound. There's two others that we almost always want to do in Python. It's actually more than two. But the two that we almost always want to do is we need to print things occasionally, right? We've seen it before. When we have something in Python, we can say, go in our print statement, and it shows up in our console. What that does is that internally calls a method that's built into everything in Python. It's way up at the top. Everything we do in Python inherits from this class called object. And it has several things already built into it. But we want to override some of those. Override is the most misused word in Hollywood. Override means change the default value. So next time you're watching a movie and the main character says they're going to try overriding it and see if and then that ends up saving the day. Imagine that character saying, I'm going to try changing the default value. And the plot becomes even more ridiculous than what it was to begin with. It's like the most misused word in Hollywood. I guess it sounds fancy, but override means change the default value. So there's a default version of equality. When we want to put things in a condition and say each two things equal, use the equal sign or the is keyword. That's going to call this built-in method that everything inherited, and that's going to be underscore underscore EQ underscore underscore, and then we'll pass in some other object to see if that's what we're equal to. We'll define what that method means. And we also want to be able to print stuff. So another one we want to inherit is we always want to inherit string, str. And it doesn't need anything in that stuff. And when we call the print method or concatenate or that cast to a string method, that actually calls this method right here, which by default, the default one that we inherited is simply print out the RAM, the location it is in RAM. So print out the number of which bit this data starts at in the RAM chip, which is utterly useless. Right? They had to do something, so that's something that's going to be unique because there's only going to be one data. Right? There's not other data stored at the same spot in RAM, so it does give us something unique. But there are very few situations where that would actually be useful. I guess it's useful for the computer on the back end, not useful for the human. So we want to override those two default things. And equal by default is only pointing to itself. It's only equal if it turns out to be the exact same thing that we're comparing it to. Right? I is equal to me. If that makes sense, excuse me. That really bad sounding English. We have more than one way to refer to ourselves. So we'll want to go ahead and override those. So that's like the design for our object, and we're just looking at syntax. Don't want to overcomplicate it here. Probably won't do any inheritance. Yeah, I want to keep the example somewhat short, and we're not really going to look at a whole lot of inheritance. So instead of inheritance, to define what that is, I will put a sound attribute here. Because all of these we want to pass into our design. We want to get those when we create a new object from our design. And then the make sound method is what we'll do if we want to get that sound back. Is a nice big sentence. And then we'll go ahead and look at equals and string. And there's a couple others. Do I have anything big in my notes? Before I go to the other example, let me double check my notes. I've given this lecture enough time that I didn't even pull them out today. Anything else I wanted to cover from the notes? And what we're going to do is make a class. That's our keyword, which is the design or blueprint. And you can think of it like a blueprint for a home in modern America, right? Everybody's familiar with subdivisions. We have lots and lots of those in Indiana. A subdivision with 30 houses, but every house in the subdivision is a 2-bedroom ranch with a garage and a basement. We see a lot of those in Indiana, right? 2-bedroom ranch, garage and a basement. So they're all built from the same design. Somebody made a design for a 2-bedroom ranch with a garage and a basement. And the subdivision is all made from that, but they are also all unique. Some of them have the garage on the left and some of them have it on the right. Some of them have oval windows in the door, and some of them have triangle windows in the door. Some of them have a porch that goes all the way across the house, and others have a small porch that only goes like halfway across the house. It's subtle differences that make each one unique, but they're all built from the same blueprint, from the same design. Talk about that. We have some other ones. There's also an init method for initialize, and that's going to be our constructor. That's how we make a new object. We have to use that every time. I have this in my notes. I probably put it in the notes because one of the textbooks I've used for this class. We also have one with double, all of them, all the things we inherit from object have double underscores. We also have a new one. And I can't remember which textbook it was from, but I just put that in my notes to do the whole big red circle with a line to it. Like, don't touch that one. I just put it in the notes to say, do not mess with this at this level. And it's a very bad idea to mess with it when you get to a higher level. This is the one your Python interpreter is going to use. So if you go changing things, you change how the interpreter operates, how the interpreter interacts with the CPU. So we have access to it, but it's a really, really, really bad idea to ever touch it. And there's a bunch like that. There's a LT and GT. They're like less than or greater than. Go along with the equal. We'll just look at equal and string. String is the default output. If we say print and then doing our object name, what do we get back? So we usually want to do that. We want to be able to print our object. What does it mean to print it? And equal, we want to do some selection structures. What does it mean for our object to be equal to another? What does it mean for two animals to be equal? I mean, they have the same name. They make the same sound. Same age. We have to, that's unique every single time. So we always have to define it ourselves. So not really an answer to that question. There's lots of answers to that question. There's lots of different ways we can define that. But that's the question you have to ask every time is what does it mean for two of our objects to be equal to each other? That way we can run a selection structure with them. Last of the blueprint. You know, we're going here. I'm just double checking, make sure I didn't skip anything from the lecture notes, but I've given this lecture a couple of times. This class runs almost every single semester. There's a lot of people that need this one. Do those concepts start kind of make sense? Object-oriented programming itself is probably sounding confusing. And building your own objects, you've been using objects for a while, so using them is no problem. But building them takes a little bit of practice. Takes a while to get good at it, like anything new. But the big advantage, we won't really see in this class. The big advantage is when we have lots of objects and it starts to look like that tree of life I was drawing. We get to think like a human again, instead of like a programmer. But when we put together, that's how our objects interact with each other. When we put together each individual object, we still have to think like a programmer. So we won't really get to that advantage in this class. It's just going to seem like something confusing and different and tedious to work with, but it will pay off in a big way soon as you progress further. I assume silence there means no questions, so let's go ahead and look at this in an example. Is Winston still here? Are you still here, Winston?
I am. Sorry, can you hear me?
Yes.
Okay.
Did that work with Spider last night?
I honestly haven't even got to try it yet.
Yeah, because what we were having trouble with earlier was with Pygame. We're going to put Pygame in Spider. There was something missing there, but it worked in the other one. So if you go back to the default version installation of Python, the default installation should work. Let me point this out. Instead of that email, if you go to Tools and Preferences, under the Python interpreter, we specifically repointed to a different interpreter so that we could install Pygame in the other class.
Yeah.
If you go back to the default installation, the default one there, the other option, it should work perfectly fine for our class here.
Okay.
I completely forgot about it until you sent that email. Let's see, so I'll create a new one. And the guard statement is important here. For the same reason, you never want to use your code in the same file that you define it in. So in one file, we're going to set up our design or blueprint, but we never want to create one of those objects in that file. Because otherwise, we would never be able to use that anywhere else without automatically creating that same one. Because we have to import that file in order to use it anywhere else. So you always want to design it and use it in two separate places. So our guard statement makes sure we're running the correct one. Okay. So to create this, everything inherits from object implicitly. We don't have to say that. So we'll just create a class, and as far as the notation, it'll look like it doesn't have a parent. So our keyword is class. And then that Python syntax thing I've talked about a few times. Keyword followed by something unique to our situation. And it's going to be the class we want to design. So I want on the board animal. And then some parentheses. And what goes in parentheses is the parent that we inherit from. So we're not inheriting. We don't have to say object. So right now, the only thing we want to inherit from is that Python object itself. And then any subclasses of this, we would have to put animal in that parentheses in order to inherit this stuff. But for us, it'll be just empty parentheses, then a colon. And now we can start putting together methods and data fields. And we set up our data fields inside of our method. The first method we always want to do every time is a constructor. That's what actually gets called when we ask for a new instance of an animal object. So we'll define a method and notice that it has to be indented to be part of that class. Just normal Python syntax there. And then it's two underscores. It is underscore underscore. Because when you start something with an underscore, it means something to the computer. And when you follow that with another underscore, it means something very, very specific to the Python interpreter. So starting with two underscores, and init, which is actually an abbreviation for initialize. I think that word just kind of makes sense. It's constructor. This is what do we want in, what it goes in our object. So what is in it? But we want to initialize it. And the first parameter always has to be self. And on the class side, self goes in the parentheses. But when we ask for an object, self is what goes before the dot. It does misalign a little bit. I'll come back and point at that. But the first parameter, the Python interpreter will pass in the first parameter. So that always has to be self because we do not get to pass that in. The Python interpreter passes in the first one. And then we can pass in the rest of our parameters. Name, age, weight, and sound. And they're parameters here. So we just need a place to hold data when we get it. Our design just has parameters, place holding spots. And when we create a new one, then we'll send some arguments to fill those parameters, fill in those holding spots. They are all variables. Remember, a variable is a name, location, and memory. So when we set up a parameter, that is naming a location in memory. That question showed up recently. A parameter is a special type of variable. And an argument is used to fill a parameter, and that's a filling a variable. So an argument is an assignment to a variable. They're just a very special type. Variables in the entire category of things. And a parameter and the argument that gets assigned to that parameter are a very special type of variable. Name, age, weight, sound. I'll put all that stuff in. And then a colon, normal for a method. And then what we want to do is we want to reassign those parameters to that self object that the Python interpreter passed in to the design. So we'll kind of rewrite that. So self dot name equals name that was passed in. And those do not have to match. I could call this one in and this one name. It is pretty common for them to match because they only look the same to us. And they don't even really look the same because that dot permanently locks the one on the left-hand side to the self. So it's pretty standard to go ahead and use the same word because otherwise it gets confusing, right? Otherwise we have two different variable names for the same data basically. So I'm going to go back to name, but they do not have to match. Then self.age is age. Self.weight is the weight we pass in. And self.sound is that sound we pass in. And this is how we will normally write our code, do this over and over again. But for our purposes here, I'm going to go ahead and do that private thing that I was talking about. We don't really have private data in Python. So what we do is we have a semi-static data, which isn't immediately available. We shouldn't directly access it this way. And to make it semi-static, we add double underscores to all these with the self. So instead of self.name, it's self.__name. And self.__weight and __ sound. And I'm going to leave it off the age one for a second to show you the difference. So I'm going to get rid of this print statement and straight pass. So we'll keep doing stuff. And I'll go ahead and save this. And I'm going to save this with the name animal. So I'll go in here, make a new folder, call it objects. And in that folder, I will call this animal.py. And then that's something we can import into another script in a few minutes and use it. But for right now, I'm just going to hit run. Where's my buttons? Okay. You lock panes into bars. Can't remember how to get my buttons back. Oh no, not that. Toolbars. File toolbar, there it is. View, panes. Oh no. Toolbars. Run toolbar, that's what I actually need. I'll go ahead and turn all of them back on. I don't know how they got turned off. Debug toolbar, the main toolbar, and the current working directory. There we go. I don't know how those got turned off. We have control over that sort of thing. But now I have my run button back. So I'm going to hit run. Go ahead and run that. It's fine. So it ran. And A is an animal object. And notice over here in the IPython console, it knows about it. So that's kind of like, we imported it to the console of the terminal. Not in the console, but you might be doing it in a terminal. But once we run it, until we reset the terminal or the console, it knows about that thing we just ran. So I can ask for it here to do some examples. So A is an animal, and let's give it a name. Fido sounds like a good name. Fido sounds like a puppy, so maybe 2 years old. Medium-sized dog. And Fido makes the sound woof. So now if we just print that out, here's the default. What it prints out by default is a string. We have an animal with a big number there. Don't look at that anyway, James, so you can see that. It's right behind the Zoom calls. That's not what I meant to do. Click that button, and then if I put that right about here, that should be out of the way. And then that just tells us what memory slot on the RAM chip that's stored at. But I can say ask for things. So like A.age, notice that's the one I left the 2 underscores off of. We can directly access that. It's 2, or we can reassign it. A.age equals 4. So a couple years later when he comes back, and then when we go to print that out, we reassigned it just by directly accessing it through the dot. And y'all seen the dot many, many times, right? Kind of know what that means. But our other ones, the ones with the underscore, if I try that with name, and like in this case, A is what is the self parameter. So A is what the Python interpreter is going to pass into everything in our class to fill that self parameter. That's why it has to be first. So it goes inside our methods as a parameter, but when we ask for it in our code, it's out front. It's the thing we write out front that gets filled by self. If we ask for a.name, notice it says there's no animal object name. We have to go a long way around to get it. We have to type this. All of this, we have to type all of this stuff to get the name with those 2 underscores. So that's where that double underscore thing, and that's how we kind of do private data. This is going to be the only example I do in class that has the private data. Usually we just bypass that in Python, but it exists. So in order to get name, we'll need our an accessor method. Or to change it, we'll need our mutator method. So that's why those we're talking about in the book. Or we always call them getters and setters. So we need something like get name. The first parameter has to be self. And if we're just asking for the name, we don't need anything else. So get name, and then the getters always look the same. We want to return self dot underscore name in this case, but whichever one we're looking for. We'll also need a setter or a mutator in case we need to change it. We say set name. Again, self parameter is always first. But if we're changing it, we need to know what value we're changing it to. So I'm going to make one called new name. And self dot underscore name is going to be assigned whatever new name is. Those don't have to match. Most people would just put name in both spots. It helps to make it a little bit clearer, but I did that above and wanted to make sure you can show that it does not have to match. It's just convenient to match them. And then we want getters and setters for all of our stuff, right? Get age. We don't need anything if all we're going to do is return self underscore age. Define set age, self, and we need to know what the new age is. And for that, our age data field is gonna be, whatever was there is gonna be replaced with the new age that was passed in. Define, get sex weight. Do you see a pattern forming on these? They're all exactly the same. Almost like it doesn't take any thought whatsoever to write it after we've defined our data fields. We have our data fields, and then afterwards, these are all exactly the same. They do the same thing. Doesn't really take any thought. So usually that's something we would generate the code for. I'm not going to show that button in this class, but if it doesn't require any thought to type it, the computer is much, much better at typing it than we are. And so it's a good place for generated code. And what we have to do is just think about which data fields we want, and then we generate all our getters and setters, or at least the ones we want. So weight and set weight, self and new weight, and self dot weight is assigned the new weight. So if we want to be able to change any of those, we would set up all our getters and setters. But I mentioned earlier that it's for a protected list. So you're probably not going to want to do what I'm getting ready to do here. How many of these things in our doctor's example would we really need? Is the animal's name going to change? Their age, it'll change, but we can easily calculate it, right? So really the only setter we would need would be the weight setter. So we could delete the rest of it. You probably just want to comment them out in yours. So highlight them and comment them out. Or in general, you probably don't need to necessarily include them in every case. So think about when you need to include them, and then it protects your data, because there's going back to that pretend that it's private, even though we don't have private in Python. We're going to pretend like it's Python, and then there's no way to get to our data. It's private. It's locked down. No outsiders can get to that data. So if we leave off the methods of the getters and setters, unless we absolutely have to have it, our data is nice and safe there. So a layer of protection. I'll go ahead and make all of them. So like get sound, since this is just an example, return self dot underscore sound. And for set sound, self and new sound, and then self dot underscore sound is assigned new sound. And then those two I said, then we'll do a make sound method. Define make sound. Again, self is the first parameter. And this is going to be our default, right? I'm going to count this as like the doctor walking in and asking, how are you doing today? Or make the doctor wanting to hear the sound you make, right? That's something the doctor wants to hear. So I'll just return the sound 3 times. Return. I'll turn it into a string. It should be a string, but I'm just going to turn it into a string. Oh, it's going to be a string. So whatever it is, plus a space, plus whatever it is again, plus a space, plus whatever it is again. Which I didn't actually type it here, right? I just kind of marked out where it's going to go. Because to access it, we need to do that self___ sound. But actually that's not the best way to do it. Once we have our getters and setters, you always want to use a getter and setter once you create them, even in other methods, because any child classes of this parent will get the methods. And then the methods will work the same for the child. But if we use data fields in the methods, the data fields might behave differently between parent and child. So you always want to use the methods. We don't want to use the say sound or self___ sound. If we refer to it directly, that could mess up in child classes, which we don't have here, but we'll just go ahead and jump to the end. So instead of that, we'll say self.get sound. We'll use that getter in order to access the sound thing. And then I'll copy that and paste it in here and here. So if it's a dog and the sound is woof, when they make sound, it'll go woof, woof, woof. Or a cat, meow, meow, meow. Or a fish, bloop, bloop, bloop. Fish make splash, splash, splash. Whatever sound we decide to put there. But a lot of that should look familiar. Setting up methods to just carry out that task we need so we can ask for it whenever we need. The big thing is the self parameter there in our class, setting things up that way. And we can leave out the double underscores. Most people usually do. This will probably be the only example in class where I use them. Afterwards, we'll go the easier way where we can just access it directly and we don't need to get it or setter. It's better form to do it this way. But now to our last two methods. There's two things we inherited from the parent. Actually, let me run it. So if I clear this and say animal is a new animal. This time I'll do a cat. So it's named Fluffy. Age 7. I have no idea how much cats weigh. They don't seem very heavy, maybe 12 pounds. And sound, meow. So there we have that. But if we try to say print animal, print animal, that's not very helpful to print out. So that's what our toString method does. Or if we had another one, we clear that. Also have something called furball. And animal is that. Furball is that. So those are not stored at the same spot in memory. Those are I just changed the reference value. I just stored changed the variable holding it. Those two things should probably be equal. Right? That has every one of our data fields equal. So, but if we ask, is furball equal to animal? Actually, I don't need the if statement because this isn't pre-scripted. I'll just write the condition, is furball equal to animal? We get false. Because the default looks at those two locations in memory, and you can see those are not the same location in memory. They're close to each other as far as the size of a RAM chip. Okay? They're the same except for the last 4 digits. And 4 digits with however many bits are on a modern RAM chip is pretty close. But those should probably be the same. So that's why we want, well, for one, that's not what we want to see when we hit print. And we want to know what equal is. So we need to override the one we inherited. Override, change the default value that we inherited from object, because we do not want our string to just say where we're at in the random chip. That's not very helpful at all. I guess that situation we just looked at right now is the only place where that would ever be helpful. If we want to see if those two things are stored in the same spot in RAM. And they're not. I think we could have probably figured that out without looking at it because they're two different things. So underscore STR, and anytime we call that STR, the cast to string method, this is the method that gets called. So all those objects have it. Or when we say print and then the object, it calls this method right here. So we'll need the self, and then we're going to return a string that represents our object. So maybe something like this is plus self.getName plus who is a plus self.getAge plus year old who goes plus self.make sound. That sounds like a good string. This is Fluffy, who is a 4-year-old and goes meow, meow, meow. That sounds like a much more useful thing when we say print it, right? So I'm going to save that and run that. I'll clear what's in the console. And then I'll say fluff is a new animal object. That looks familiar. We've done a few things like that, right? Last week we were doing it all the time. We'd open a new file handler object. We've created a few things that way. User number is an input and then some stuff in parentheses. So an input object. We've been doing this since the beginning. The difference is we're making our own objects now. So fluff is an animal. An animal needs a name. So fluffy needs an age. Fluffy is 7. I have no idea how much cats weigh, so I'm going to guess 12, and he goes meow. So now if we say print fluff, we've seen that message before, right? Self.age is string, so an integer, so we need to cast that as a string. Name and sound should be strings. So let me clear this and run that again. And scroll up where I get that line. So there we go. And now if I print fluff, there's no make sound. Oh. Anybody want to tell me where what happened? Should I make sound? Anybody want to say what I did wrong there? Nobody has any thoughts? Oops. And what did I accidentally close? I did not mean to make something maximize. And where'd the console go? That looks like files. Okay, that's not what I meant to do. Come over here and where did the console go? Why is it way over there? Undock. And dock it here. Oh. There we go. Nobody sees what went wrong? There's a little typo there. Could be a make sound thing over here somewhere. Make sound instead of max sound. Now, if I clear that and run the file again, with those changes. Eventually, it'll hopefully print out. Oh, there was something in the chat room. There we go. So there's that string message. So if we just say print, then we get something meaningful for our data. So we always want to make sure and include that. The other one we always want to include is to set equality so we can do checks. There's also less than, greater than, but for us here, just go ahead and start with equality. So underscore equal. And we need self, and then we need, what are we comparing it to? We need something else that we're trying to compare this to see how it works, see if they're equal. Some sort of object. And if I'm going to run this method, is instance. So if is instance, if object is an instance of animal, then we can check. If it's not an animal, they're definitely not equal, right? If we can't compare Fluffy the cat to Hello World the string, those obviously wouldn't be equal. So first thing I want to check is instance. So if the object, the thing we passed in, that parameter object, is of the class animal, then that'll return true. And then we can set our condition, because if it is, then we can say if self dot get age, I'll just do age, is equal to object dot get age. And I know that will be okay because we already checked to see if it's an instance of animal. And if it's an instance of an animal object, then that means it does have a get age method. That seems like a good thing to do a comparison on. At least quickly for our syntax. So if the ages are equal, we'll return true. But if the ages are not equal, whoops, else return false. This will be exactly the same as it was in it. I started to do another one and come back out and say else return false. But that will behave exactly the same. You want to stare at that code for a second? Does that make sense? First of all, really that's an and situation. That might look a little bit neater. Let me change that to an and, because it would look a lot neater. Nesting ifs is the same as and. So if it's an animal and that happens, then return true. Otherwise, it's false. That looks a little bit cleaner for the example. It's exactly the same, it's just nested if statements, putting an if block inside of an if block will give you the same thing as an and situation. It just looks a little bit different. So that gives us a way to tell if things are equal. Oops, clear this and run the new version. So now I'll make a fluff is an animal with the name Fluffy. Is 5 years old, weighs 9 pounds, and goes meow. We'll have Spark, who's an animal. His actual name's maybe Sparky, who's 1 year old, weighs 28 pounds, and goes woof. And another one, I'll just call it Fish, is an animal named Fishy. For first off, I'll say he's 3 years old and weighs 1 pound and goes splash. So right now we shouldn't have any equality. We can print all of them though, right? Oh, if we say fluff, we get that, but if we say print fluff, see that. Or actually, these should probably be over in something we can adjust, right? Let's look at that to finish it up. I'm going to copy these lines. Well, I'll just do it over here. Create a new file, and I'll go ahead and save it so I don't forget to later. And I'll put it in the same folder and call it zoo.py. That sounds like a good name for it. And then the first thing we want to do is import animal. If we're in the same folder, we get the first place it's going to look for another file is in the same folder. So it'd be okay to put that here. And then we can do those other lines. And then we don't have to keep typing them over there. So there's Fluff and Spark and Fish. So then we have our stuff. I'm gonna get rid of the guard statement. That'd be fine. Fluff and Spark and Fish, and we can print them. Print Fluff, print Spark, print Fish, print Spark dot make sound. Those other methods that we've called from it, and I'll do a quick equals. If Fluff is equal to Spark, print Fluff and Spark are the same. Elif Fluff is equal to well, I already created them, right? Yeah, so we can set it over here. So like Fluff equal to Spark. You see, initially is false, but if we were to change those values, Sparky's 1, the Fish is 3. So if we were to say, oh wait, that's the cat. The dog is 1 and the cat is 5. So if we were to change that dog one, so say Spark dot set age, reassign that to 5, and then check if those are equal. Oh, I was expecting it to return true. Maybe I have to say is. Oh. Well. Oh, yes, it is. Spark.setAge is a method, so then we pass in 5. Oh, whoops. Wait. Why is that not callable? Int is not callable, it should be. Set age, so spark dot set age, and the new age gets assigned to the age. I'll do it over here. And I'll just print it instead of putting it in there. So print fluff equal to spark. We know that's false. But then we can call that method and say spark dot set age. Well, maybe that's the problem. Spark is an animal. There's the predictive text. Oh, actually, I skipped something. The predictive text is missing in something. So we imported animal, the file, but we've seen that before. If we want to type it here, we need to type animal.animal. Sorry, I just overlooked that. Now the predictive text would work, but that'll be a mess. So I'm just going to do the as a, make it easier to type. So I'll say a.animal, a.animal, a.animal. And now I should be able to do spark dot, there is that stuff. If we set age and make the new age 5, then we should be able to print fluff equal to spark and see that become true. Unless I made another typo, because I'm not really sure why it's saying int is not callable earlier. That's weird because that method most certainly should be callable, and I'm not really sure where that's even pointing. Line 1 is blank in the file, so it's, the error message is clearly not telling me the correct thing. So if we save that, oh, put my cursor back in the right spot and save that. If we run that, we'll see all those things. So we created the animal, and usually want to do it like this. If you try to use it in the same spot you design it, you can never import it without automatically running that use in the design. So design it in one file, and then import it into another file, and then do all your using here. To see, we got those printouts, and then print out the make sound one for the dog. We get a similar thing for the other ones. And Fluff and Spark are not, they're both animals, but they're not the same age, so they're not equal. And then when we reset the age, they do count as equal in the last one. That's the ones we want to cover every time. That's the good form. That's probably the only night, tonight's probably the only time we're going to do those double underscores and use getters and setters on everything. That is good form. You want to do it, but you'll notice it definitely takes a lot longer in a classroom than if we would have just set up the data fields and used the dot to access everything. It's a nice time saver when we only have a couple hours a week to talk about this. But a quick pass on the syntax, and now we have our own unique data type that fits the situation. So I was thinking we would be finished about 20 minutes earlier than this, and then we could quickly make one that fits with that running example, that payroll thing. We could make a data type for that, an employee data that has the name, rate of pay, data fields for all that. And then that's what we store. So that we don't have a bunch of different data to deal with, we have our own custom data type that is perfect to fit our needs. That's what an object is, that's what a class is. There's the basic syntax for it, and in good form, and for the rest of the semester, we probably won't use good form for classes. For developing our classes anymore, we'll do the quick and easy one because it's quicker, and we are very tightly constrained in time in the classroom. Y'all have seen and had it pointed out what the good form is. Keeps our data fields nice and safe, and we don't have those behaviors to work with. It takes some practice getting used to it. It's different. And I pointed out at the beginning, the biggest advantage is that we can think like a human again when we make lots of our own classes and then turn those into objects. We get to think like a human again on how things are organized. But unfortunately, we don't see that at the first level. So that's further down the road. It will pay off in the long run. Right now, it's probably hard to see, so just practice the syntax, and try putting your code together. That way, it's going to build into something that everything else you see on software development is pretty much a study in object-oriented programming. The general advantage is that it's better for a human. So even though it's hard to see at the introduction level, you'll be able to do 1,000 times more with a lot less work once you get used to it. Takes a little bit of practice though. Well, we got 20 minutes left tonight, so a few minutes to click around and do things. Does anybody have any questions before we wrap up? I should check the chat room with those questions there. I don't see any questions in the chat room or this one. Sometimes DMs come to this one. Okay. That was a few seconds of silence. I assume silence means no questions. If you have any, let me know. I'm always happy to help. I should all have a great evening. I will see you on Wednesday. As always, I don't strictly require attendance. I take it. So if everything's recorded, right? If you have like long traveling to do for the holiday, and you would prefer to start before 9 o'clock on a Wednesday, I will definitely understand. If you do a lot of traveling over the weekend and do not have time to get stuff done by Monday because you're completely overwhelmed with American tradition events that you're obligated to and can't get out of to do homework, which, by the way, that was why Python was created. He's muddled down the story, but he couldn't get out of the family event, so he made up an excuse that he had to work on this project so he could get out of talking to them. Keep that in mind while you deal with your family over the weekend, or while you enjoy your family's company over the weekend. That an excuse to get out of talking to them when he couldn't get out of going to the event was to make up this project. So he kept telling them about it, started working on it, and by the time he got back to work a week later, he knew he was onto something great. And it is by far the most popular programming language. Something to think about as we head towards the Thanksgiving holiday, but don't be like him. Enjoy your family's company, which means you might, if you need an extension on the homework, let me know. Otherwise, you all have a great evening. I'll see you on Wednesday, next class, all that, what's going. Have a good one.
I have just a quick